If there is one predator that seems to rule the oceans without hesitation, it is the killer whale, an animal so intelligent, coordinated and powerful that it hunts in organized family groups and takes down prey far larger than itself, dominating ecosystems from polar ice fields to tropical waters, with a level of control that few other species on ocean can match. For decades, marine biologists have studied orcas as apex predators, documenting their complex communication, their strategic hunting techniques, and their extraordinary ability to adapt to different marine environments, which makes one particular observation deeply unsettling. There is a specific region of the ocean that these animals consistently avoid, altering their migration routes in ways that cannot be explained by simple coincidence. It is an open stretch of deep ocean that appears at first glance no different from the surrounding waters. Yet when researchers map satellite tracking data collected over years of monitoring, a clear and persistent pattern emerges, revealing an empty space in the middle of otherwise extensive migration routes. Orcas travel thousands of kilometers every year, crossing entire ocean basins in search of food, social interaction and breeding grounds, moving confidently through icy Arctic seas, temperate coastlines, and equatorial waters. These are animals that do not fear sharks, that thrive in deep and unpredictable waters, and that have survived in some of the most extreme marine conditions on the planet. So when a species with that level of dominance and adaptability repeatedly chooses not to enter a particular stretch of ocean, scientists are left with a question that challenges everything we assume about predator behavior and environmental awareness. What could exist in that part of the sea that is powerful enough, dangerous enough, or disruptive enough to redirect an apex predator? To understand why this avoidance is so unusual, we first need to understand what orcas truly represent in the marine world, because these animals are not simply large dolphins roaming the sea, but highly organized predators with advanced cognitive abilities, strong social bonds, and hunting strategies that rival the coordination seen in wolves or lions on land. Orcas live in tight family groups known as pods, and these pods are built around complex social structures that can last for generations, with knowledge passed from mothers to calves through vocal communication and learned behavior, creating distinct cultural groups that specialize in different hunting techniques depending on where they live and what they eat. Some pods focus almost exclusively on fish, using precise movements and coordinated waves to herd schools into tight formations, while others hunt marine mammals such as seals or even large whales, working together with remarkable patience and strategy, sometimes exhausting prey over long distances before delivering a final, calculated attack. Their intelligence allows them to adapt to a wide range of environments, from the freezing waters near Antarctica to the warmer regions closer to the equator, and their bodies are built for endurance, speed, and power, making them one of the few species that truly sit at the top of the oceanic food chain, without natural predators threatening their survival. Satellite tracking and long-term field research have shown that orcas are capable of traveling across entire ocean basins, navigating using a combination of memory, environmental cues, and possibly even the Earth's magnetic field, which gives them an extraordinary level of awareness of their surroundings and allows them to exploit vast marine territories with confidence. Because of this adaptability, scientists rarely observe consistent large-scale avoidance patterns in orca populations, unless there is a very strong environmental factor involved, such as a drastic lack of prey, extreme changes in water chemistry, or persistent disturbances that interfere with their ability to communicate and hunt effectively. That is precisely what makes the unexplored gap in their migration routes so intriguing, because it is not a minor hesitation or a temporary shift in behavior, but a repeated and measurable deviation that suggests these predators are responding to something significant within that stretch of ocean. Before we examine the region itself and what makes it different, it is important to recognize that when an apex predator alters its course in such a consistent way, it often signals that the environment holds forces more powerful than we initially imagine. If you are interested in uncovering mysteries like this and understanding how science reveals the hidden patterns of our planet, consider subscribing to the channel, because each episode explores real phenomena that challenge what we think we know about the natural world. The area in question lies in a remote stretch of the open ocean, far from busy coastlines and major shipping routes, positioned within a vast expanse of deep water where the seafloor drops thousands of meters below the surface, creating an environment that, to an untrained eye, appears no different from the surrounding sea. Oceanographic maps show no obvious barriers, no visible landmasses, and no dramatic surface features that would immediately explain why a highly mobile predator would change course. Yet when researchers overlay years of satellite tracking data from multiple pods, the pattern becomes unmistakable, revealing a consistent detour that curves around this specific region rather than passing directly through it. This observation first drew attention when marine biologists began comparing long-term migration records, noticing that pods traveling between feeding grounds and breeding areas were adding extra distance to their journeys, sometimes covering dozens or even hundreds of additional kilometers, as though responding to an invisible boundary drawn across the ocean's surface. What makes the pattern even more compelling is that it does not appear to be linked to seasonal prey movement, because nearby waters support healthy populations of fish and marine mammals, and other large predators continue to move through the area without displaying the same level of avoidance. Researchers have also ruled out obvious environmental extremes, such as dangerously low oxygen levels or massive temperature shifts, since standard oceanographic measurements indicate conditions that fall within ranges commonly tolerated by orcas in many other parts of the world. Yet beneath the surface, this region is not entirely ordinary, because it sits above complex geological formations on the ocean floor, where tectonic activity, underwater ridges and deep-sea trenches interact with powerful currents, creating a dynamic system that influences water chemistry, pressure gradients, and acoustic properties in ways that are still being studied. Some scientists suspect that subtle changes in underwater sound transmission could play a role, since orcas rely heavily on echolocation and vocal communication to navigate and hunt, and even small disruptions in how sound travels through water might interfere with their ability to coordinate as a pod. Others point to unusual magnetic anomalies recorded in parts of the region, suggesting that variations in the Earth's magnetic field could affect animals that use geomagnetic cues for navigation, potentially creating disorientation or discomfort that encourages them to reroute their path. Whatever the exact cause, the consistent avoidance documented over years of research indicates that this is not a random detour, but a response to environmental factors powerful enough to influence one of the ocean's most capable predators. When a behavioral pattern repeats itself across different pods and over long periods of time, scientists begin to look beyond coincidence and search for underlying mechanisms. And in this case, the theories range from geological forces hidden beneath the seabed to subtle environmental factors that humans can barely detect, but marine mammals might perceive with extreme sensitivity. One of the leading hypotheses involves underwater acoustics, because sound travels through water far more efficiently than through air, and orcas depend on echolocation clicks and complex vocal signals to hunt, navigate, and maintain social bonds, meaning that any disruption in how sound waves move through a specific region could interfere with their most essential survival tools. If the geological formations beneath that area distort sound transmission, scatter acoustic signals, or create unusual reverberation patterns, it could make communication less reliable, which for a species that relies on tight coordination may represent enough of a disadvantage to justify avoiding the region altogether. Another theory focuses on geomagnetic anomalies, since many migratory animals are believed to sense variations in the Earth's magnetic field, using it as a kind of natural map. And if that stretch of ocean contains irregular magnetic signatures caused by tectonic structures or mineral deposits in the crust, it could disrupt internal navigation cues and create a form of sensory confusion. There is also the possibility of chemical factors rising from deep-sea vents or tectonic fractures, because hydrothermal activity can release minerals and gases into surrounding waters, subtly altering water composition in ways that may not appear dramatic in surface measurements, but could still be detectable to animals with highly refined sensory systems. Some researchers even consider long-term evolutionary memory as a factor, suggesting that if, at some point in the past, that region presented consistent danger or ecological instability, generations of orcas may have learned to treat it as unfavorable territory, passing that avoidance behavior culturally from one pod to the next through social learning. None of these explanations has been conclusively proven, and it is possible that more than one factor is interacting at the same time, creating a combination of acoustic distortion, magnetic variation, and subtle environmental instability that makes the region less predictable and therefore less attractive for a species that depends on coordination and precision. After years of satellite tracking, acoustic analysis, geological surveys, and behavioral studies, the truth is that we still do not have a single definitive answer that explains why orcas consistently avoid this particular region of the ocean, and that uncertainty may be the most important part of this entire story. We know that these animals are not impulsive wanderers drifting aimlessly through the sea, but highly intelligent predators capable of long-distance planning, social learning, and precise coordination, which means that when they alter their routes in a consistent and measurable way, they are responding to something real within their environment, even if that something remains partially invisible to us. It may be a combination of distorted acoustics that interfere with echolocation, subtle magnetic irregularities that disrupt navigation, or chemical variations rising from deep beneath the ocean floor. And it is entirely possible that multiple forces overlap in that region, creating conditions that feel unstable or unreliable to animals whose survival depends on clarity and coordination. What makes this situation so compelling is not the idea of danger in a dramatic sense, But the possibility that these predators are perceiving environmental signals that our current instruments only detect in fragments, suggesting that their sensory world may be richer and more complex than we fully understand. In many ways, this avoided stretch of ocean becomes a reminder that despite satellites, deep-sea probes and decades of marine research, vast portions of our planet remain largely unexplored, and the behaviors of animals like orcas may be offering clues about hidden dynamics taking place beneath the surface. When a species that confidently hunts great white sharks, that survives in freezing polar waters, and that dominates marine ecosystems across the globe, decides to change course around a silent patch of sea, it forces us to reconsider how much we truly know about the forces shaping life in the deep. Perhaps the most unsettling possibility is not that there is something extraordinary in that region, but that it is part of a complex ocean system whose signals are simply clearer to them than to us, raising an uncomfortable but fascinating question. If apex predators are responding to patterns we can barely perceive, how many other invisible boundaries exist across the oceans of our planet, quietly shaping the paths of life while we remain unaware of them? Thank you for watching this episode. If you are fascinated by the mysteries of the deep ocean and the behaviors of the world's most powerful predators, consider subscribing to the channel so you can join us in the next exploration. Until the next video.